Hey everybody, and welcome back to Stanton 101. In today's pre-calculus video, I will be covering ellipses. This includes learning how to find the major and minor axes, how to graph an ellipse from general form, how to locate and plot foci, determine the equation from the vertices in the foci, and discuss the parametric form of the equation of an ellipse. I know this may seem like a lot, and maybe you don't need to know all of this, so there will be timestamps in the description to use at your disposal. Okay, so first of all, we need to go over the general, or the standard form of an ellipse. The standard form of an ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. In this form, the center is located at h, k. Similarly, a will be the semi-major axis and b will be the semi-minor axis. All of this is assuming that A is greater than B, of course. The way to calculate the semi-major axis is 2 times the quantity A, and the minor axis will be 2 times the quantity B. The foci can be found by the equation f squared equals p squared minus q squared, but this will be used later, and for your reference, that is the equation that will be used. This here is the parent graph of an ellipse. A is located on the x-axis and B is located on the y, and the center is at the origin. The foci will be plotted on both sides of the major axis equidistant from the center. Now let's do a practice problem. Here is x squared over 64 plus y squared over 16 equals 1. Since there is no h or k, we can determine that the center is at the origin. Now let's go ahead and graph it with each dash representing a jump of 2 units. We know that it is centered at the origin. Now all that has to be determined are the lengths of the semi-major and semi-minor axes. I have already graphed it, but will now show you how I came to this conclusion. You can determine that you go up 4 and 8 across on both sides of the center to determine the vertices of this ellipse. A equals the square root of 64, or 8, and B equals the square root of 16, which is 4. The foci can be determined by the formula of f squared equals p squared minus q squared. This is 64 minus 16, which equals 48. This must then be square rooted to get 4 root 3. This is approximately the quantity 6.9, so we can go ahead and plot those points 6.9 units away from the origin on both sides of the semi-major axis. Let's move on to a sample where the center is not at the origin. In this problem, we have x plus 4 squared over 25 plus y minus 2 squared over 9 equals 1. This means that the center is located at -4, 2. Now we have to find A and B in order to plot the graph. In this case, A equals the square root of 25, which is equal to 5. B equals the square root of 9, which is equal to 3. This graph will also take jumps of 2 in order to save some space, since the jumps are very large. The center is plotted at -4, 2. The semi-major axis is 5, so if positive or -5 is added to -4, you can get the quantity of -9 and +1. Similarly, the y-coordinates are 5 and -1, both 3 units away from the center vertically. The foci can be found by f squared equals p squared minus q squared. This means we must subtract 9 from 25 to get 16. You can see that p and q are also the same things as the quantity a and b. To get f, you must square root 16 like you did with b to get 3. When we do this, we get f equals 4, so we can plot the two foci at 0, 2 and -8, 2. Let us move on to an example that is not in general form. Here in this next equation, we have 6x squared plus x 8y squared equals 24. We need to divide everything by 24 in order to get the equation that allows the graph to be created. This will give us x squared over 4 plus y squared over 3, which equals 1. This graph will take jumps of 1 unit each since the measurements aren't too large like the ones that we did before. The center is located at the origin and the semi-major axis is 2, while the semi-minor axis is square root 3, which is approximately 1.7. The foci can be found by taking the square root of 4 minus 3, which is just 1. The foci will be plotted 1 unit to the left and 1 unit to the right of the center. Now, what we can do is that we just find that you have to divide everything by 24 in order for the equation to be solvable. Here we have a different type of problem. This gives you the foci at positive or negative 5, 0, and the vertices at positive or negative square root of 41, 0. The foci can be determined by the formula we have been using, which is f squared equals p squared minus q squared. Here we will have 25 equals 41 minus q squared, which can be arranged as q squared equals 41 minus 25, which will give you 16. This will be shown in just a little bit here on the screen. This equation can be used where f is the focus point, p is the semi-major axis, and q is the semi-minor axis. A little tip to figuring out if you use p or q to find f is if you look at the two coordinates. If both of them give you the x coordinate, then you use p to find q. If it gives you the x on one and the y on the other, you use q to find p. Now here is the 25 minus 41, 41 minus 25 equals q squared. Now we can figure out that since q squared is 16 and will be plotted under the y coordinate of the equation, that the equation will be x squared over 41 plus y squared over 16 equals 1. Since p is always greater than q, p will correspond with the x-axis aspect of the equation if there is a horizontal major axis, or the y part if there is a vertical major axis. Since both x coordinates are given, that means that the foci are located on the x-axis, making x the semi-major axis, and that is where p is located. The next problem that we have will be 0, plus or minus the square root of 62, and plus or minus 5, 0 as the vertices, and the foci are located at the top. F squared equals p squared minus q squared can be used here, where 62 is f squared and it equals p squared minus 25, since 5 is q and not p, because it's on the minor axis. To isolate p, we add 25 to both sides of the equation, which gets us 87 equals q squared. We have all the necessary tools to get the equation now, and the final product will be x squared over 25 plus y squared over 87 equals 1. 25 is q squared because the x-axis is the minor instead of the major axis. This is known because the two sets of coordinates are opposites. Anyways, this equation will be your answer down here. Next, we will move on to parametrics. In parametrical form, x equals a cosine t and y equals b sine t. We can determine the parametric equations of both x and y from this new problem here. The parametric equation of an ellipse is simple. If we assume that the variable is t for time, we can find out what the point on the ellipse will be at any given moment. The value of a in the x equation equals the value of a in the x equation on the right, and the same thing for b and b. A we can determine is the square root of 4, which equals 2, and b is the square root of 25, which equals 5. All that is left is to plug in a and b in their respective equations where t equals time. X equals 2 cosine t, and y will equal 5 sine t. This wraps up parametrics and also the entire video. So thank you so much for watching, and stay tuned for many more videos to come, hopefully. Thank you!